Greetings once again from the shores of Rainy Lake on the Canadian border of northern Minnesota. It's a very nice day. It's about 67 degrees at the moment. There's a nice breeze coming up off the lake, and I'm looking due north right at the moment into Canada. And this is a spot that along this line is where I set up my targets for the survey last winter. But because of the breeze and the fact that we have an overcast sky, there isn't much heating going on the surface of the water today, and there's very good mixing going on with the air, and the temperature is very uniform, and there's very little refraction going on today occurring. And I'm going to show you something before I get started on the pressure measurements regarding the curvature of the earth. Now, if you notice the shore in Canada, that at the water level there's white rock, and that tends to be about 6 to 10 feet high above the water, and the tree line comes down to that and stops. And this is very characteristic of the shorelines around here. You can see the rock, which goes up, 6 to 10 feet depending upon where you are on the shore. And what I'm going to do is sight some shoreline in the distance. I have a shot 5 miles out and 2 miles out, and you can see what the difference is and how the shore will be hidden by the curvature of the earth. Okay, I'm looking a little bit northwest into Canada, towards Canada, and if you notice in the center of the frame there's a little red triangle marker. That's a channel marker that's exactly 2 miles from this spot, and it's on the American side, it's on the American shore there. But again, notice the rocks just above the water level. You see the white rocks there on the shore, and in the distance past the marker there in the light green, that's Canada 5 miles away. And notice you can't see the rock shoreline, and you can see the water in the way there. And then if I pan over here, that island is at about 4 miles, and again, you're not really seeing the shoreline. And now these islands over here are about 3 miles away, 2.5 to 3 miles, and you can see the rocks on the shoreline. Again, I'll pan back. There we are 5 miles out, and you can't see any of the shoreline. It's being hidden by the bulge of the earth. The water is hiding it, and that marker there is on what's called Franzen Island, if you care to look on Google Maps, in northern Minnesota, that little channel marker. And then to the right of that there are the rock outcroppings, or the rock shoreline. And again, I'll look again. You can't see it over there in Canada, 5 miles away. That's a cabin over there. And then when I come back to this island, which is about 3 miles, you can start seeing it. Again, I'll zoom in. We're looking at the point there, Franzen Island. You'll see the marker come into view. And then in the distance is the Canadian shore. George Nonchik again. This is part 2 of the pressure test experiment that was presented yesterday. We're going to do a few more tests just to verify some of the hypothesis conjectures that we had regarding the positive pressure, the slight positive pressure that was generated in the straight tube when there was uniform laminar airflow going down the tube. I've set it up again, this time on the trailer. And you can see it's the same as what I had yesterday, except that I've reversed it. Yesterday I had the air being pushed in on this end and exited on the far end, where this amount of tube was used for the exit. There's only about 7 inches between the hole in the tube and where it exited, so we just had this amount that was possibly causing some air resistance in this portion of the tube as the air was exiting, which caused a little bit of air to come in through the tube because of the air resistance, creating a little bit of pressure, kind of back. You can think of the air being backed up and coming up into the tube. Now what I've done is I'm going to shoot air in on this end and then have 67 inches worth of tube creating air resistance, and we'll see if it makes any difference in the amount of pressure, positive pressure, that gets developed inside the tube here. Okay, the shop vac is connected up. And make sure that the balloon is pumped down. So now I'll start up the shop vac. Definitely there's more positive pressure being pushed into the tube because the balloon fills up faster than it did yesterday using the shop vac, when we used the shop vac to shoot air down the tube, and I couldn't collapse the balloon as easily to push the air out as happened yesterday. So now what I'm going to do is go ahead and reverse the airflow to like it was yesterday, except the difference will be is I'm going to cut this end off so that there's very little air resistance, and we'll see if there will be even less positive pressure developed in the tubing than there was yesterday when we had this amount. Now first, reverse it and show again, once again, the effect this section has on, and then I'll cut it off and then we'll do it again. Alright, the apparatus is hooked up just like it was yesterday. The shop vac is now connected to the long end of the tube, and the exit is on the last 7 inches of the tube from the point where I have the hole drilled into the sidewall. As you can see here, this is where the sidewall was drilled, and we have the tube connected there, and the last 7 inches is the exit, just as I had yesterday. We'll see what the rate is for blowing the balloon up, which will indicate how much pressure is being developed. So now I'll turn the shop vac on. that the rate is very slow compared to what it was when I was blowing air in on this end. Plus it's much easier to collapse because this isn't any resistance to speak of. Now you can see that it blows up real fast if I just plug the end. Okay, so now what I'm going to do is cut off this section and repeat the test, and we should see that possibly there will be even less air pressure being developed in this tubing than we currently see. Okay, can now see that I've cut the end off. This is the end that used to be there. So that's cut off. We only have about 1 inch from the center of the air hole to the end. Collapse the balloon here, and I will turn on the shop vac and we'll see what happens. Blowing up very slowly. There just isn't much positive pressure here at all. Now if I plug the hole, of course, now for the next experiment, what I'm going to do is I cut a little piece, a little hood that I'm going to glue on the inside over the hole. And what this will do is create a little hood, and the air pressure or the airflow will be going over. It'll be faster on the top side, so it should create a fairly good negative air pressure on the inside. So we'll do that and see what happens. Okay, we're now ready for our last test. You can see that I've now mounted a hood over the hole on the inside of the pipe with the exit facing to the rear. This will now force the air up and over and to increase its velocity and create a lower pressure at the exit. So this should generate now a negative pressure in the outlet. So now we'll test that out. So now start the shop vac. Now I'll blow up the balloon, and we see that it pumps it down. So we no longer have positive pressure in the hose because of that little hood over the hole. So, the tests performed on the pipe show that our predictions have been correct. Mathematics and science does work. After viewing my last video, someone had asked me what do I use this Hallmark trailer for. And what it is storage at the moment for my electronic gear that I use in my business. It's filled with network analyzers, spectrum analyzers, RF signal sources, counters, everything to do with designing electronics, anywhere from DC up to about 3 gigahertz. But that's basically what's in here, is just a lot of inventory for the business. There again is the marker on Franzen Island. Now I'm looking over, I'm about 60 feet up above, 70 feet above the water right now. You can see the smaller islands that were hidden by the curvature of the earth. When I took the picture at the introduction, I was about 10 feet up above the water. I'm about 60 feet higher now. Boat. But again, that's the direction I was looking at. The trees just behind the red triangle, the channel marker, is 5 miles out. You can see that smaller island there and some of the reefs in front that we couldn't see when I was 10 feet above the water. And a lot of the detail on the islands there, you can see the rocks that we couldn't see before. Here we see the Google Maps on Rainy Lake on the view that I was just showing on the videos at the beginning and here at the end. From my observation point, looking over northeast across the lake, over Franzen Island, the marker on Franzen Island that had the little red triangle, which is 2 miles away, and on over to the Canadian shore. Rather than being 5 miles away, it turns out it's 5.88 miles away to that island that we saw the light green trees on. over in the background from Franzen Island. Now, Franzen Island is right here on the tip of my marker. The tip of that island is where the marker is, Franzen Island. And it turns out that that's actually, let's see, 1, 2, 3, 4, 5, 6, 7. That's 2.7 miles, not 2 miles. It's 2.7 miles from my observation point. The observation point is back here. I'll be giving you the coordinates at the end here, the GPS coordinates of the observation, the marker on Franzen Island, and then the target distance here on the Canadian island over here at 5.88 miles. Franzen Island marker again is at 2.7 miles, and my observation point here is on the shoreline on Rainy Lake. Now the coordinates will be here. I'll zoom in on those for you. So you can see my observation point is at 48.614863 latitude by minus 93.307866 longitude. The marker on Franzen Island is at 48.627686 latitude by minus 93.251734 longitude. And the Canadian shore over there at 5.88 miles is latitude 48.642887, longitude minus 93.186846. Here we have a view of Canada looking north over the lake. That's 2.5 miles away. You can see a bit of Highway 11 in Ontario, the causeway that goes 250 miles from island to island heading east to Thunder Bay.